Question number 4. The angle of elevation of the top of a tower from a point on the ground which is 30 meter away from the foot of the tower is 30 degree. Find the height of the tower. First of all, we need to make figure. Okay, so we consider here AB is a tower. AB is one tower where A is the top of tower and B is foot of the tower. Now, from a point on the ground, that means we take a point C on the ground which is 30 meter away from the foot of the tower. Now, foot of the tower means point B. So, point C is 30 meter away from the point B. That means our BC is equals to 30 meter. Okay. Second thing, angle of elevation is given. Again, read the question. The angle of elevation of the top of a tower from a point on the ground which is 30 meter away from the foot of the tower is 30 degree. That means from point C, angle of elevation is given 30 degree. Angle of elevation, that means angle created between line of sight and the horizontal in upward direction. That means angle C is equals to 30 because this is our angle of elevation. Okay. Then we need to find the height of tower. Now what is the height of tower? It is AB because AB is a tower. So AB is height of tower. We need to find AB. Okay, so this figure is already drawn here. Now with respect to this 30 degree, BC is given. BC is our adjacent side. We need to find height of tower. That means AB. AB is opposite side. So which trigonometric ratio gives the relation between adjacent side and opposite side? It's a tan theta and cot theta, right? Tan theta and cot theta, but right now we use here tan theta. We go for the tan theta. So here theta is equals to 30 degree. That's why tan 30. Now formula of tan 30, opposite side upon adjacent side. Opposite side AB with respect to 30 and adjacent side it's a BC, so divided by BC. Now value of tan 30 is equals to 1 upon under root 3. We can write therefore in two ways. Here we need to put therefore 3 dots, otherwise this arrow. This both symbol is used to define therefore. Okay. Now opposite side AB, that we need to find. That's why as it is upon BC. BC is equals to 30 meter. Now transfer this 30 to the left hand side. So our AB is equals to, now 30 goes to the numerator. So 30 ones are 30 divided by under root 3. Now again in our answer under root present in denominator. So we need to rationalize it. So either we can multiply and divide by under root 3. Otherwise we can factorize our numerator, that means 30. So AB is equals to here 30 upon under root 3. Now in place of 30 we can write 10 into 3. In place of 3 we can write under root 3 into under root 3. So 1 under root 3 cut. So final answer is equals to 10 under root 3 meter. Here value of under root 3 is not given. So this is our final answer. So height of tower is equals to 10 under root 3 meter. So at last we need to write height of tower is 10 under root 3 meter. Question number 5. A kite is flying at a height of 60 meter above the ground. The string attached to the kite is temporarily tied to a point on the ground. The inclination of the string with the ground is 60 degree. Find the length of the string assuming that there is no slack in the string. So we can show our string by one straight line because there is no slack in the string. That's why. Now one kite is flying at a height 60 meter above the ground. So if we consider our point A is a kite, then it is 60 meter above from the ground. B is point on ground. Okay. So kite A is a 60 meter above the ground. Then second thing, the string attached to the kite is temporarily tied to a point on the ground. So I consider one point C. So AC is one string, right? So string attached with one point on the ground. It is point C. So AC is string of kite. Okay, what we need to find? That means we need to find the length of the string. Now AC is a string, so we need to find the length of string. That means we need to find AC. One more thing is given, that is inclination of the string. Inclination of the string. String is AC. Inclination of the string with the ground. BC is ground. So this string AC and ground BC makes angle 60 degree, because it is given that the inclination of the string with the ground is 60 degree. That means our angle C is equals to 60 degree. Okay, because inclination of the string with the ground is given 60 degree. AC is our string and BC is ground. So string AC makes 60 degree angle with the ground. Okay, so this is our final figure. We need to find AC. Now with respect to angle C, AB is opposite side and we need to find AC. It is hypotenuse. So which trigonometric ratio gives the relation between opposite side and hypotenuse? It's a sine theta and cosec theta, but here we use sine theta. We can also use cosec theta. Okay, so sine theta, here a figure is already drawn here. A is one kite, C is point on the ground and AC is string. So sine 60, because here angle is equals to 60 degree. So sine 60, opposite side AB upon hypotenuse AC. Now value of sine theta, it is under root 3 by 2. Sorry, we need to write here 60, because angle is 60 degree. Okay, so sine 60 is under root 3 by 2. Then AB is 60 and we need to find the AC. Here AC is in denominator, so we need to transfer it to the numerator. Here total two way we have. First of all, transfer this AC to the left hand side, so it goes to the numerator. Then transfer this under root 3 by 2 to the right hand side. Here 60 is already present. If under root 3 by 2 is transferred to the right hand side, then 2 is in denominator, so it goes to the numerator, and under root 3 is in numerator, so it goes to the denominator. Okay, then we can find the AC. So AC is equals to, now 60 multiply 2, it's a 120 upon under root 3. Now we need to rationalize the denominator, otherwise we can do in place of 120 we can write 40 into 3. Now in place of 3 we can write under root 3 into under root 3. So under root 3 cancel, so final answer is 40 under root 3 meter. Okay, so length of string is 40 under root 3 meter. Now second thing, if we do not transfer AC to the left hand side, then we can understand like this. Just take a inverse to both the side. Just take inverse of both the side. So first of all, inverse of left hand side. Now inverse of under root 3 by 2, it's a 2 upon under root 3. Just we need to transfer our numerator and denominator. Same thing in right hand side. Take a inverse of sine upon AC. So it becomes AC upon 60. Right? Now AC, it is in a numerator. So just transfer this 60 to the right hand side. So finally we get AC is equals to 60 into 2 upon under root 3. So in this way we can find AC. So 120 upon under root 3. If we do not get a logic of factorization, then we can rationalize the denominator, then multiply and divide by under root 3. Okay, this way we can also use here. So in numerator 120 under root 3, and in denominator under root 3 multiply under root 3, it's only 3. Then 120 divided by 3, it's a 40. So same answer we get here, 40 under root 3 meter. Question number 6. A 1.5 meter tall boy is standing at some distance from a 30 meter tall building. The angle of elevation from his eyes to the top of the building increases from 30 degree to 60 degree as he walked toward the building. Find the distance he walked toward the building. Now here, one more thing. It is here height of observer is given. Okay, height of observer is given. That's why we need to consider it. In above 5 question, we neglect the height of observer. Okay, but here one person is there, one boy is there, and height of boy is given. So we need to consider the height. Now, what is the question? 1.5 meter tall building is there. Okay, I give name AB. And one boy is standing at some distance from the building. One boy is standing and height of that boy is 1.5 meter. Here I give name P and here I give name R. So PR is equals to 1.5 meter. Okay. So a 1.5 meter tall boy is standing at some distance from a 30 meter tall building. So AB is building and PR is boy. Now the angle of elevation from his eyes to the top of the building increases from 30 degree to 60 as he walks towards the building. A boy is walking towards the building, that means in this direction. So initially a boy is standing at position R, and from that point the angle of elevation. Now angle of elevation, that means angle created between line of sight and horizontal. So AP is line of sight because P is eye of observer and A is object, that means top of building. So AP is line of sight, right? Line of sight. Now we need to draw the horizontal at point P because angle of elevation is given with the horizontal. So here we draw one horizontal line and I give name C. That means this horizontal line intersect building AB at point C. So the line of sight, that means this AP and horizontal. The angle of inclination is, angle of elevation is 30 degree. First of all 30 degree. Now suppose if a boy walk towards the building and reach at point Q. Boy walks toward the building and reach at point Q, and from point Q the angle of elevation is 60 degree because it is given in the question. If boy walks towards the building, then angle of inclination, angle of elevation is increases from 30 degree to 60 degree. So initially boy is standing at position R. At that place angle of elevation 30 degree. He moves toward the building and reach at point Q, right? So from Q the angle of elevation increases from 30 degree to 60 degree. That's why at point Q angle of elevation is 60 degree. If boy reach to the point C, then the angle of elevation is 90 degree, but here it is given to 60 degree. That means a boy needs to walk up to the point Q where the angle of elevation is 60 degree. That's why up to Q we draw here. Okay, so this is our final figure. Here we know the AB, height of building it's 30. We know the height of boy, it is 1.5 meter. Now what we need to find? Find the distance he walked toward the building. Now boy is initially at position P. Final position of boy is Q. So distance traveled by the boy, it's a PQ. Okay, distance traveled by the boy, it is PQ. So we need to find the length of PQ. Okay, we need to find PQ. It is the distance traveled by the boy. Second thing, in real life situation, even if we move towards any object, then we need to raise our head to see the top of that object, right? If building is there, if we move towards the building, then we need to raise the head. That means angle is increase if we move towards the building, otherwise any object. If we move towards, then angle is always increase. Now figure is already drawn here. We can see from the figure here two right angle triangle is there. First is right angle triangle AQC, right, and second right angle triangle is APC. So two right angle triangle we have. First of all, we need to find one side of this right angle triangle. After that, we can find the other sides, right? So first thing, now AB is 30 degree, but from C to B, it's a 1.5. Why? Because this makes a rectangle. So PCBR is a rectangle. So opposite side of rectangle are same. So BC is also equals to 1.5. So we can find AC. So from 30, just minus this 1.5. So remaining height is a AC. So first of all, we can find AC. So here it is written that AB is equals to 30 and PR is equals to 1.5 meters. So AC is equals to, AC means this portion is equals to whole portion minus this lower portion. That means whole portion AB minus BC. Now BC and PR both are same because it is the opposite side of rectangle. That's why. So we can write PR in place of BC. Now we know the value of AB and PR. So just put the value. So AB is 30 and PR is 1.5. So 30 minus 1.5. So AC is equals to 28.5. Okay, AC is equals to 28.5 meter. Now we need to think about how can we find the PQ. So first of all, from triangle AQC, we know this side 28.5. We know this angle 60 degree. So we can find QC from here, right? We can find QC from here. Now second triangle is ACP. Again we know the height of AC is 28.5. Now this time angle P is equals to 30 degree. So again by using this triangle we can find the length of P to C, right? Now how can we find PQ? If we subtract QC from PC, it is PQ. Means this total distance minus this distance QC. So we can find PQ from there, right? So PQ is equals to whole PC minus QC. Now QC we can find from the first triangle, PC we can find from the second triangle. And if QC and PC we find, then after that by subtraction process we can find the PQ. So same thing we use here. So first of all, consider triangle ACQ. So here it is written that in right angle triangle ACQ. Now here AC is opposite side. We are trying to find QC. QC is adjacent side. So which trigonometry gives the ratio between opposite side and adjacent side? It's a tan theta and cot theta, but we use here tan theta. Okay. So here tan 60 because angle theta is equals to 60 degree. Opposite side it's a AC. Upon adjacent side it's the QC. Now value of tan 60 it is under root 3. AC we find 28.5 and upon QC. Now we need to find the QC, right? So transfer this QC to the left hand side and is this under root 3 to the right hand side. So here in left hand side QC is equals to 28.5 upon under root 3. So this is our QC, 28.5 upon under root 3 meter. Now QC is not our final answer. That's why right now we do not rationalize it. Okay. When we get our final answer and if under root is present in denominator in our final answer, at that time we rationalize the denominator. Right now QC is not our answer. Okay, that's why we do not rationalize it. Then second thing, consider triangle ACP. Right, so in triangle ACP, tan 30 is equals to, now for ACP, here 30 degree, opposite side AC, upon adjacent side, now it is PC, right? So AC upon PC. Now put the value of AC and put the value of 1030. 1030 is equals to 1 upon under root 3. AC is equals to 28.5 upon PC. PC we need to find. So as it is. Now for finding out PC, we can either take inverse, otherwise we can transfer PC to the left hand side. So transfer PC to the left hand side. It goes to the numerator. Right, so PC into 1, it's a PC. Now transfer this under root 3 to the right hand side. Under root 3 it is in denominator, so it goes to the numerator. So PC is equals to 28.5 under root 3. Okay, so PC is equals to 28.5 under root 3 meter. Now we find distance PQ. So PQ is equals to whole PC minus QC. Now put the value of PC and QC. Now PC is equals to 28.5 under root 3 minus QC. It's a 28.5 upon under root 3. Okay. Now we can take 28.5 as a common. Right. So 28.5 common. Then what is remaining? Here under root 3. Then negative sign. And here 28.5 is common. Then nothing is remaining in numerator. That's why 1. And in denominator under root 3. Right. In denominator under root 3. So 1 upon under root 3. Now take LCM. So 28.5 as it is. Now take LCM in this bracket. So under root 3 into under root 3. It's only 3. Then negative sign. Then this 1 as it is divided by under root 3. So 28.5. Now 3 minus 1. It's a 2 upon under root 3. Now here we need to rationalize the denominator because this is our answer. That's why. So here multiply under root 3 and divided by under root 3. So first of all in numerator 28.5 into 2. It's a 57 under root 3 divided by under root 3 into under root 3. Only 3 and 3 is cut with 57 because 19 3s are 57. So finally we get 19 under root 3 meter. So at last we need to write this. Distance traveled by the boy is equals to 19 under root 3 meter. Okay, in our final answer we need to rationalize it. That's why we multiply and divided by under root 3. So finally we get 19 under root 3 meter. Question number 7. From the point on the ground, the angle of elevation of the bottom and top of a transmission tower fixed at the top of a 20 meter high building are 45 and 60 degree respectively. Find the height of the tower. So first of all we need to draw the figure. So it is given that a transmission tower is fixed at the top of 20 meter high building. So first of all one building is there. We give name AB to the building. Right? AB is building. Then on the top of building one transmission tower is there. That means from point A one tower is standing there. I give name C. So AC is our tower. Okay. AB is building and AC is a tower. Now from one point on the ground, I take one point P on the ground. Now from point P, the angle of elevation of bottom and top of tower are 45 and 60. So first of all, angle of elevation of bottom. Now what is the bottom of transmission tower? Transmission tower is AC. So point C is the top of transmission tower and point A is bottom of the transmission tower. That is already written here, right? Top of tower and bottom of tower. Now from point P, the angle of elevation of bottom of tower is 45 and from point P, the angle of elevation of top of tower, it's a 60 degree respectively. Okay, so first angle is for bottom and second angle is for top because at last it is written that respectively. Respectively means sequence wise. So bottom of tower, that means point A have angle of elevation 45 degree and top of tower, that means point C have the angle of elevation is 60 degree. Now height of building is given. It is 20 meter, right? We need to find the height of the tower. We can give name h to our height of tower. Otherwise, we can also write AC. Okay. So we need to find AC. Now how can we find it? So first of all, we just find relation between these two triangle, because two triangle we have. Right now I rub this because this figure is already drawn here. So total two triangle, right angle triangle we have. One is A, P and B. Now second right angle triangle. It is P, B and C, and one point A is here, right? Now here angle 45 is 60 degree. Here 20 meter, here 20 and h, so totally 20 plus h, right? Now from triangle APB, we know one angle, we know one side. In triangle PBC, we know one angle, but we don't know any one side of right angle triangle. 20 plus h, but we don't know the value of h. That means we know only angle in triangle PBC, right? We need to find h, and h is present in triangle PBC, second triangle, right? So if we know any one side of this triangle, then we can find h. Okay, so we need to know about either PB, otherwise PC. We want the value of PB, otherwise PC. So we can find h from here. So for that, here one side PB and here also one side PB, because PB is common side in both the triangle, right? So if we use first triangle, then one angle is given 45 degree, one side is given 20 meter. So we can find PB from first triangle, right? We can find the value of PB from first triangle, and if we find value PB from first triangle, so we can put that value in second triangle. So we know one side PB, we have one angle 60 degree, and by using that we can find height of BC, and if we find height of BC, then we can find h. So this way we can use here. So first of all, just consider triangle A, B and P. From that we need to find PB. Okay, so in a right angle triangle, first of all use the triangle ABP. Here it is given CBP, but we are not using it. First of all use the triangle APB. So in triangle APB, here A, B and P, here 45 degree and here 20. Okay, so tan 45, because here AB is given, it is opposite side, and we find here PB, it's the adjacent side. So tan theta gives the relation between opposite side and adjacent side. That's why we use tan here. We can also use cot, but right now we go for tan. So tan 45, opposite side AB upon adjacent side, it's a PB. For P, two adjacent side PB and AP, but AB we take as a hypotenuse, that's why we written here PB. Okay, so put the value of AB and tan 45. Value of tan 45, it is 1. AB is 20 meter. We need to find PB. So transfer this PB to the left hand side. So PB into 1, it is PB, and in right hand side is equals to 20. So PB is equals to 20 meter, right? PB is equals to 20 meter. Now use the second triangle. Now second triangle. Here angle 60 degree for triangle C, B and P, because point C have elevation 60 degree. It is top of tower. Now what is the length of BC? It is 20 plus h, because one A is there up to A. Height is 20 and AC is equals to h. So alternately we can write like this, 20 plus h, right? We already find PB, it is 20 meter. Now in this triangle, we know adjacent side. we need to find opposite side. So which trigonometric ratio gives the relation between adjacent and opposite? Tan theta and cot theta, but we use tan theta here. Okay, so use the tan theta. So here tan 60. Opposite side is BC right now. Adjacent side is PB. Now I rub this triangle. So what is the length of BC? It is a 20 plus H upon PB. PB we find 20 meter and tan 60 it is under root 3. Now transfer first of all this 20 to the left hand side. So 20 under root 3 is equals to 20 plus H. Now we want to find H. That's why transfer this 20 to the left hand side. So here 20 under root 3. This plus 20 comes to the left hand side. It becomes minus 20. Okay, is equals to H. So from left hand side we can take 20 as a common because both terms have 20. So 20 common. So here what is remaining? 20 cut because it's a common. So under root 3. Then negative sign. Nothing is remaining here. That's why I written 1 is equals to H. So our final answer of H is equals to 20 in bracket under root 3 minus 1 meter. This is our final answer. 20 in bracket under root 3 minus 1. Here value of under root 3 is not given. That's why we do not put the value of under root 3. Otherwise value of under root 3 is equals to 1.732 and value of under root 2 is equals to 1.41. Okay, but here value is not given. That's why we do not put the value of under root 3. Then this is our final answer. 20 in bracket under root 3 minus 1.